story begins with inertia. Physics is about movement, how things move and why things move. Here is a very large thing. What do you notice about it? It's not moving. Go ahead and try and move it. You can't. It doesn't want to move. Is that because it's so large? Try and move a smaller thing then. Well, you managed to move that a little way, but it was a great effort. It was as if it still didn't want to move. Even tiny things are reluctant to move. Even a pebble takes some effort to shift. This is the first rule of physics. Things like to stay where they are. Unless there is some force to push or pull it, no object in the universe will start moving of its own accord. It's as if all objects were lazy. But why is physics about movement if nothing wants to move? The answer is that there are lots of things in the universe that pull or push on objects and force them to move, whether they want to or not. You force the pebble to move. And since things are lazy, you'd expect your pebble to try and stop moving as soon as possible, wouldn't you? Well, you'd be wrong. Strangely enough, although when the pebble was at rest, it wanted to stay at rest. Now that it's moving, it wants to keep on moving. In fact, it would like to keep on moving forever and ever. The only reason it slows down and eventually stops is because things in its path force it to stop. The resistance of the air, or a tree it bumps into, the roughness of the ground. But if there were no air or rough ground or trees to get in its way, if you were in outer space, for example, when you kicked your pebble, it really would go on moving forever and ever. It would never stop. So how can we say that objects are lazy? If the pebble's moving, it's not being lazy, is it? Yes, it is. It takes just as much effort to stop moving as to start moving. You get a feeling for this when you're ice skating. When there's hardly any resistance to your movement and it's easier to keep on gliding along than to stop. The same goes for the pebble. If nothing gets in its way, if nothing helps it to stop, it will have to make all the effort to stop by itself. And it's much too lazy to do that. We can now modify the first rule of physics from things like to stay where they are to things like to keep on doing what they're already doing. If a thing is at rest, it wants to stay at rest. If it is moving, it wants to keep on moving. In other words, there is lots and lots of laziness in the universe. Physicists have a special word for laziness. It comes from Latin. Inertia. Eureka! The story so far. Things like to keep on doing what they're already doing. They don't like to start moving or stop moving. They are lazy. Another word for laziness is inertia. And now, mass. A large thing is equally difficult to move and to stop moving. Whereas a small thing is easier to move and easier to stop moving. The big rock has more inertia than the little rock. It is lazier than the little rock. Are all big things lazier than little things? Does inertia always increase with size? Oh, really? Well, why don't you take a huge cube of styrofoam and try to throw it? And catch it. Then do the same with a small cube of lead. Do you still think big things are lazier than little things? The small cube of lead was more difficult to stop moving than the big cube of styrofoam. In this case, the small thing was lazier. It had more inertia than the big thing. So inertia doesn't always equal size, or volume, or bigness. In fact, when we talk about how much inertia a thing has, it isn't really a question of how big it is, but of how massive it is. A massive rock, for instance, is a rock that contains masses and masses of stuff or matter. It's not merely big, but also solid and chunky, like a massive bulldozer or a massive ball player. You don't push things like that around very easily, any more than you can stop them easily when they come charging at you. They are too massive. Because of this, scientists took the word mass as a measure of inertia. The more the mass, the more the inertia. In spite of the fact that the styrofoam cube looks much bigger and more important than the little lead cube, it doesn't contain as much stuff. There's much less to it than there is to the lead cube. It has a far smaller mass. But just how much is a lot and a little when you're talking about mass? To find that out, we have to go to a place called Sèvres, near Paris in France, where a particular piece of platinum has been very carefully preserved. Scientists all over the world have agreed to call this little chunk of metal 1 kilogram, which is very convenient, because if you take a balance and put this piece of platinum on one pan and put any object you like on the other, a pebble, let's say, then if they balance exactly, you know that the pebble has a mass of exactly 1 kilogram. But what about the cube of lead? That feels as if it has a lot more mass than the 1 kilogram pebble. Well, all we do is put the cube in one pan of the balance, have a whole lot of copies of the platinum kilogram made up, pile these standard kilograms in the other pan until they balance the lead cube, and then count how many there are. 1, 2, 3, 4, 5, 6, 7, 18, 19, 20. There! Now we know that the lead cube has a mass of exactly 20 kilograms. Of course, we can do the same with the big important-looking cube of styrofoam. 1, 2... Sorry, you have only 2 kilograms of mass. So the lead cube has 10 times more mass than the styrofoam cube. Which explains why it's 10 times more difficult to push around.